Well, algebra students, we have quite an interesting problem on our hands here in Chapter 1, Lesson 8 of the book, Interpreting Graphs. What this video is hopefully going to show you is kind of give you a basic idea of what all these terms mean on the right side of my screen. Intercept, symmetry, positive, negative. And then we're going to use this graph as our example to learn what all of these terms mean. So what I'd suggest is that you watch this video through, taking notes, and then you go back and try to solve all the problems, identify all of these features on the graph yourself without the answers. So go through it once with to learn the answers, and then try to go through it yourself again to see if you can do it. Okay? We're going to start off with the intercepts. Okay, so we've learned about intercepts. Intercepts are the places where your graph crosses one of the axes. There's my x-axis, and there's my y-axis. In this case, let's start with the x-intercepts. I'll call them x-int. It looks like the squiggle, the graph itself, crosses the x-axis in how many different places? 3. This point right here, this spot, and this spot. And so for the x-intercepts, you just list those ordered pairs out. -4, 0, comma, -1, 0, and 3, 0. Pause the video, see if you can find the y-intercept. Okay, so for the y-intercept, it turns out there's just one of them, and that's going to be right here at 0, -12. That's where that curve, the graph itself, the red, crosses the y-axis, 0, -12. So there's my x and y intercepts. Now we get into the new stuff, all the new stuff. We'll start with symmetry. Symmetry basically says, is there any line that I could draw on my graph so that it would make a mirror on either side of the line? For example, if you drew a line down the middle of a person, there would be symmetry there. Is there any line where we could draw a line and this graph would be the same on the top and the bottom of the line? Or if we drew a vertical line, the graph would be the same on the left and right of the line. So the answer is no, this graph is not symmetrical. It's got kind of a short loop and a longer loop here. No symmetry going on here. It's not like a human being or an animal or a circle where you can split it evenly in half. So no symmetry. Next up we get to positive and negative. Positive and negative simply refers to parts of your curve. And when I say curve, I mean this whole red graph squiggle thing that we have. Positive and negative refers to the parts of your curve that are above the x-axis or below the x-axis. It's as simple as that. We're looking for any part of this whole squiggle that lies above that x-axis line that I'm highlighting right now, or below the x-axis line. If it's above, we'll call it positive. If it's below, we'll call it negative. So as we follow this whole squiggle, it looks like it starts in the positive range. Right here it goes down into negative. It stays negative, just touching the x-axis, and staying negative, all the way up to here where it goes positive again. So how do we describe that in terms of math and in terms of notation? Well, we can see that going off to the left here, it seems to be positive with no end. You can keep going and going as far left as you want, and it would stay positive. It would stay above the x-axis. The way that you would describe that in terms of our notation would be positive when x is less than -4. So when the x-coordinate is -4 or less, it looks like that graph is going to be in that positive range. When else is this graph positive? It's going to be positive when x is greater than, well, let's look over here. Once x hits 3 and keeps going up farther and farther to the up and to the right, it's staying positive as well. So when x is greater than 3. Okay? So positive when x is less than -4, and positive when x is greater than 3. Remember, positive just means that it's above the x-axis. What about negatives? Where would we describe where this graph is negative? Well, anywhere between -4 and +3, this graph is negative. In other words, the y-coordinate is negative. So we would say negative when x is greater than -4 and x is less than 3. So when we're describing the positive and negative, even though positive and negative have to do with whether the y-coordinate is positive or negative, we're going to describe it in terms of the location using x. When x is between -4 and 3, that's when y is underneath the axis, okay? So hopefully you can see that it's positive above that line, negative below that x-axis line. Next up we get to increasing, decreasing. For this one you simply want to picture a little person right here. See if I can draw a little person, maybe not. I want you to picture a person here. Here's my little person, I'll call him Stephen. And Stephen is starting on the left side of the graph. Here he is, there's his head. And he is walking from the left side to the right side of the graph. The graph is called increasing if Stephen is walking uphill, and it's called decreasing if he's walking downhill. So starting here, it looks like he starts within a decreasing path all the way to there where he starts increasing, decreasing, and increasing again. Okay, that's Stephen's path here. So let's see if we can describe that again in terms of x's, or how we're going to describe it. Okay, so it looks like it's decreasing when x is less than, so all the way from the left up until x is, I'll call that about -3. -3, okay, we can do a little estimating here, we don't need all the decimals here, okay? It's also decreasing, this part is increasing, but then it decreases again when x is -1 all the way to when x is about 1.8. So we'll say x is between -1 and 1.8. And is there anywhere else where it's decreasing? No, it just keeps going uphill after that. So here's how you would write it. And the notation I'm not trying to be too exacting about. I just want you to understand that it's decreasing when x is less than -3 and when x is between -1 and 1.8. Okay, so why don't you pause and try to figure out where the graph is increasing. Okay, well, looks like Stephen's going to be walking uphill, increasing from about -3 to -1. So increasing from x is -3 to -1. Then it goes downhill. And now it's increasing from about 1.8 and onward. So, and when x is greater than 1.8. Okay? Increasing and decreasing. We're getting close, guys. We're getting close. We are now up on end behavior. End behavior refers to what is happening at the ends of your graph. This graph has two ends. This end of the graph, where the graph ends, and this graph, where the graph ends. Now, in reality, it could keep going, but we only see this part of it. Let's start with the left end. The way you describe end behavior is simply what is x doing and what is y doing. In other words, is x going left or right if we were to continue this line? And is y going up or down if we were to continue this line? Well, if you look at it carefully, it looks like x is decreasing because it's moving farther to the left. Y is increasing because it is moving up. Okay? Now, this can be confusing, but this increasing and decreasing is different from the increasing and decreasing that we did before. This is only just referring to, is x getting bigger or smaller, and is y getting bigger or smaller. Okay, so why don't we, just so we don't get confused, why don't we say x is getting smaller and y is getting bigger. Okay, why don't you try to describe the end behavior of the other end here, and then we'll answer it. Okay, so for the other end, on the right, x is getting bigger because it's going to the right, and y is also getting bigger because it's still going up. And there's your end behavior, okay? There's your end behavior. All right, folks, we're almost done. It's time for local extrema, okay? Local extrema are the places in the graph where the graph changes direction, okay? The graph is going down, 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 down. It's decreasing. Oh, now it's increasing. There's a local extreme. Increasing, increasing, decreasing. There's another change, local extreme. So anytime you see one of these valleys or peaks in the graph, you know that's a local extreme, or local extrema for plural. There's two types of local extrema, local maximum and local minimum. Let's start with the maximum. It looks like there's just one local maximum. Those are the peaks of the graph. And it looks like it's this point, -1, 0. Okay? So once again, we are just going to describe this in terms of the x. So there's a local maximum at x equals, what's our x coordinate here? -1. -1. Okay? What about local minimums? There appears to be one right there where x is about -3 at x equals about -3. Is there any other local minimum, any other valley? Yes, at x equals about 1.8, 1.9. X equals about 1.9. We used 1.8 before, so let's stay consistent. Okay, like I'm not going to be too hard about rounding here. Okay, so local maximum, local minimum. Okay, one more thing to note there. Your book calls those relative maximum or relative minimum. That's the same thing. Relative max, relative min. And there you have it. X-intercepts, Y-intercept, symmetry, positive and negative, decreasing, increasing, end behavior on the two ends, local extrema, maximum and minimum. Okay, I think we covered all the terms in the book in that lesson. Your job is to go back through this problem and try it again yourself from the start. You can use your other notes as a reference or use your book as a reference. The homework is going to ask you to do some more complicated things with that, but if you really understand the basics, it'll allow you to try some of the harder problems in the book. One last piece of advice, there's a lot of graphs that look like this available online. If you just Google polynomial graph, you can practice looking at graphs and trying to identify the different maximums, minimums, increasing, decreasing, etc. Okay? So try out the homework, keep up the good work. Thanks for watching.